And with that, I'm happy to do a live demo, but I would actually like to pause here to see if there's any questions on this, because I've hit the hour, and so I want to make sure that we do this, because the live demo is really not as important as being able to answer questions. Um, so
Thanks a lot, Sylvia. That was great. That's so much information.
yeah,
It'll be good that this is recorded, right? So we could watch it back and pause and everything.
yeah, do
Um,
it at like 0.75 speed, um, but or 1.5 speed, depends on what you like. So
so if anyone has a question, maybe this is a Zoom meeting, not a webinar, so people can unmute, but maybe it would be good just to raise your hand so that we can call on you so that we don't have people talking over each other. Andres, yeah.
Hi, can you hear me?
Yes.
Thank you very much for the presentation, Sylvia. It was great. There's a lot of information. I had a question just really quick. Could you repeat what you said about the memory intensive model where using less processors is actually faster than using more, because it's something that I'm facing right now in an SP model.
yeah, so I don't know which slide to go to, but I'll just stay here. So remember that you've got many analyses, right? And you want to run them in parallel. But each model has a matrix. All OpenSees is putting data into a matrix and inverting that matrix and solving the equilibrium, right? And so inverting a matrix takes memory. It needs to keep, it keeps track of, and especially some material and some elements actually need, the state. What is the current state? What is the current damage parameters, right? And so every element has its history that it must carry with it. So if you've got a large model that has a lot of elements that have a lot of history parameters that are with it, and also you have just a really large matrix that needs to be inverted, so that's a big model itself, and so it's data intensive because it needs to remember all the data that's associated with it, even the recorders and everything there. And so it's if you hit, if I run a really large model on my desktop, well, on my laptop, let's say, at some point it's going to say, hey, you've got weight, and I've got billions of elements. It's going to hit a wall, right? It's going to say, hey, I don't have enough memory to keep track of all this data. And so now shrink that into something that's manageable. And so maybe my computer can only run one such model at a time. Or it can only have, if one model requires, a certain X gigabytes, it depends on how much memory I have in my computer to be able to run, 7 analyses. If I run 14 analyses, I'm doubling the requirements on my memory. And so don't run, 56, you've got 56 processors. Don't use all 56 processors if you have a relatively large model. Maybe only run, because now you've got 192 divided by 56, and that tells you how much memory is for each analysis. And so you kind of want to share the resources and be able to give enough memory to each analysis. Of course, the memory gets managed, and maybe there's going to be some points where it requires more and some points where it requires less. But my point of it is, don't forget about memory and being able to keep track of everything that's needed. Otherwise, it may just even slow down your analyses, and now you're back to square one. And so make sure you assign the proper resources to the analyses.
So,
Thank you so
Sylvia,
much.
we have
That's
a
real
couple that
helpful.
came through the Q&A. Maybe, is there going to be a PDF of the slides available? I know that this is recorded, but PDF too?
Yeah, yes, definitely.
Okay, great. So I will put yes. And then, sorry, Andres, did you have a follow-up question?
Nope, that was it. Thank you very much.
Okay, good question.
Oh, okay.
Thank you.
Okay, thanks. And then there's a question, if we have a user-defined material, how can we use OpenSees and DesignSafe? So I'm assuming that means that user has developed their own code and compiled OpenSees from source on their own machine, I think.
Yeah, so one is you can work with the folks at DesignSafe to see if you can bring something and have it compile there. The easiest way to do it would be to compile it in Python and then just pip install it and run the Python version of it. But if you need to run the other versions of it, you need to work with the folks at TACC. And I think there is a way of being able to bring in your own local version of it, but you need it to have it compiled in-house, just because that's the configuration on processing.
And Sylvia, do you know how often we update the OpenSees versions that are available on TACC resources? Like if a user commits a material model and it gets ingested into a new version of OpenSees, how long might that?
I'm trying to get that sped up. I don't want. I've been pushing Frank to produce OpenSees executables more often than every few years, and so I think we're getting, now that he's resolved the whole makefile and everything, we're hoping to have every 6 months an update and have DesignSafe be consistent with that. There's a lot that goes on behind deciding, for a new version of OpenSees. And so Wang Yang is trying to stay along with Frank. But that's something that we've just started now to be a little bit faster in getting things out to the public.
All right, thanks. Let's see, Omid, you're next. Go ahead.
Hello. Thank you very much for doing this, Sylvia. I just wanted to ask you a question. When I do these models, like doing incremental dynamic analysis for 12 frames, 20 frames, something like that, it usually takes for 2 months when the model is huge. And at the end of the analysis, I understand that if I had that recorder, I could, I did one recorder that I haven't defined, I could interpret the results much better. And then I have to put the recorder, and again 2 more months. I want to ask you, because you said that you have access to huge storage because of the supercomputers and everything. Is it possible to save everything in the model? For example, in Abacus, this is completely possible in the post process. I want to ask you if this is possible in OpenSees.
So yes, you can. So this is more of a, so one is, I'm pretty sure there must be some limitations on the storage space, but I think you're talking about real time being able to dump everything in OpenSees. Yes, you can. Of course, you write the recorders. You have to tell it what everything is. Somebody in Abacus wrote a script that it runs internally that outputs everything. In OpenSees, you would have to write it all out. I think the MPCO recorder does that, and it may do it efficiently because it uses an HDF5 file. But my recommendation is just be careful, because as I said, the output, it takes time. It will slow down your analysis. And so if you're not outputting much and it's 2 months, if it takes 2 months, it's going to take twice as long with that much more output, because as I said, that's what takes time. And so this is why I recommend that you run a small scale. You get to know, look at your results in small scale, look at your results, think about what you're seeing in the first place, so that then you can decide what the proper recorders are. A lot of stuff can be done in post-processing. So for example, for fiber sections, if you have your axial force, moment, and curvature, you can rebuild it in post-processing so that you don't have to output all the fiber strains. If you want to output everything, make sure that you have an efficient model, that you don't have fiber sections with 7 integration points and 1,700 fibers in every element of your structure. So yes, you can output everything, but just be careful. I would just try to do something a little bit more intelligent than that, in the sense of think ahead of time before you act, which is strange for me to say, but yes. So that if it already takes 2 months, then don't make it take that much longer. And a lot of the data you can do in post-processing.
And there are memory limits. Tim can correct me if I'm wrong, but I believe everyone gets a 5 terabyte allocation when you sign up for a DesignSafe account. If you go higher than that, maybe you would have to pay for storage, but I think there's some flexibility there, right, Tim?
Yeah, as long as you're storing data on DesignSafe, yeah, you can bring or generate and save through simulations, about 5 terabytes of data.
Yeah, and
You're
it's
correct, Scott.
right, and there's connections in the data depot to Google Drives and other drives so that you can move data elsewhere to your own personal storage, and then transfer what you need. But again, one is its memory. The recorders take up memory. I wouldn't try to dump everything out because you may not need it, and so think ahead.
So the next question came through the Q&A. Masashi Kishimoto asks, is there a need to write the script defining your model in a particular way for it to be able to run on OpenSeesMP? Or do you just write the script like a normal old OpenSees script and OpenSeesMP knows what to do?
So OpenSeesSP knows what to do, except for that you have to, and if you look at the documentation, and there's a lot of things about, I mean, this is not just a DesignSafe issue. I mean, this is just about OpenSees itself. So OpenSeesSP, you just have to specify the parallel solvers. For OpenSeesMP, you write your script in Tcl or Python, however you want, but you need to know, hey, what is your processor, right? Because all the processors are running the same script. And so if you don't assign any jobs to any particular processors, you're just going to have it run 17 times or n times, however many processors you have. And you've got to be careful, because what if you're running the same script and you're outputting to the same file? I should have put that as a big notice to be careful. So yeah, if you look at examples and other videos on how to use MP, it shows you that you first have to get the number of processors, then, and there's scripts in the documentation on this, and then say, oh, if your processor is so-and-so, then you do this. If you're different processors, then you run a different analysis, and the same thing with the allocation. So the script is the same, but there's additional things you need to do to assign jobs.
Yeah, and we do have a video by Maria Giovanna that Sylvia mentioned that talks about how to use OpenSeesMP and specify a list of ground motions if you want to do a parameter study and that sort of thing. That's in our YouTube channel that you can find through the DesignSafe Learning Center. Yeah, and I've also put it on there, and I'm planning to do a little bit more on more things as I get to know OpenSeesMP to be able to do things that are a little bit more advanced too. All right, Franco, your turn.
Hi, thank you for your presentation. I have a specific question. I'm using OpenSeesPy to run uncertainty propagation analysis and parametric analysis, but I'm using the parallel computation tools that are available in Python as external tool there. Can I run this on DesignSafe or not? Yeah. Yes. Okay. What are you using? What's the tool you're using? I'm using concurrent features. This multiprocessors pool. Actually. Okay. Yeah, so I would look into concurrent futures first. It's newer than the multiprocessor, but OpenSeesPy. Now, by doing that, you're going to an external library. Okay, and so remember there. So yes, you can do this on OpenSeesPy right now. You can run OpenSeesPy on both the interactive as well as the Jupyter Lab. And so pip install what you need. I think some things may already be there. If they're not, you need to pip install them. But again, if you're going through an external library, there's a lot of expense in managing the pool. OpenSeesPy has the MPI internal to it. And so that makes it much more efficient because it's internal to OpenSees. And so, but
I'm trying to get that version of OpenSeesPy into the design safe. So yeah, right now do what you're doing. I tested it, and that's how I run my parallel OpenSeesPy analyses.
Okay.
And Franco, I'll add one thing. If you're using the Design Safe Jupyter Hub, there are only 4 cores available for parallelization. They limit the number of available cores there. So you can specify an MPI job with more than 4 cores, and it will actually run slower than if you only specified 4, because there's some overhead from all the MPI communication that happens. So if 4 is enough, that's great. If not, you could go to one of the bigger systems, but then that would require you to write your scripts in Tickle instead of Python, right?
Well, yes, that's the problem.
But he's not running it through. So that's a good question. I'll look into it, because he's not running it through an MPI. He's running it through a Python libraries. And so that actually, the way it's configured right now, it allows you to use all the cores. Just be careful, and we may need to set limits on that. But yes, I guess there's limits on the MPI, but I don't think you're running it through MPI, right? You're pip installing this multiple things. So it's a different system.
Yes, I'm taking like externally the parallel computation.
Yeah, because you
some.
Yeah, so that's the other way you could do it, is you can run MPI that calls Python through the MPI, and then that could manage the different jobs, and so then you would run it just like OpenSeesMP, but you're actually getting. So I'm working through all this to make sure that it's not so confusing. There's ways. So there's like 3 ways that you can run it in Python, and that's why I'm putting on hold on that, to make sure that I get it all resolved and documented, so it's not so confusing.
Okay, thank you.
All right, and then we have a question from Ali in the question and answer. So incremental dynamic analysis is a time-consuming analysis. Please explain how the design safe can reduce the time of analyses. Please compare the analysis time for a case study structure.
Okay, so first of all, you shouldn't be running IDAs. You should be running spectrum consistent, hazard consistent ground motions. But okay, so design safe just allows you, when you're doing an IDA, it depends on how you're running it, right? So you can either just keep on just define a set of scale factors, right? So you define a set of ground motions, you define your set of scale factors, and you run the analyses. Doing this on design safe is faster only because it gives you that many more resources. Therefore, you can run that many more analyses in parallel, because you got 56 cores per node. So you got 100 and I don't know what that is, 112, which is more than my gaming desktop has, and the space. So if you just run them in parallel, it's that much faster. Memory is bigger as well, so that means you can run that many more at the same time without having memory problems. Now, if you're running IDAs where you're looking at the results in the previous one, which is what I was talking about earlier as well. So then some things need to be run in sequence, and some things can be run in parallel. And Design Safe is just giving you the platform for you to write the script to run it the way you want to. They're doing the hardware. You got to write the script, and comparing it is hard, because it depends on if you have convergence issues and have to iterate, depends on the size of your model and things. So Design Safe is just giving you a much bigger platform to run these on for IDAs or anything else. I hope that answers.
Sylvia, I have a follow-up question. You mentioned that running jobs through the Design Safe portal to OpenSeesMP, you're limited to, or SP, or you're limited to 2 nodes, which is 112 cores on Frontera. Is that a limit that's built into the OpenSees builds, or is that a limit that's imposed on the community allocation that people use to run these scripts? And if they had their own allocation, could they run it on, say, 1,000 nodes or 100 nodes or something much bigger?
Tim is getting very giddy about this question right now. So right now, the way it's configured, the web submit is meant to be fast, and that's why, you know, the more requirements, the more you ask, the more you're going to have to wait. And so the way it's configured right now is, let's make it big but not that big. So you've got the 2 cores. If you need to run something bigger, you might as well go directly through TACC. But there are plans in the future to make it a little bit more turnkey. So then you say, okay, I want to run OpenSeesMP, and then they're going to say, what configuration do you want? Do you want to run it in the small queue, which is 2 nodes, or do you want to run it in the regular queue, which is X nodes? And there's different ways that there's allocations or configurations of the nodes in TACC. And so eventually that's going to be, because I'd like to be able to do what I had to script and wait and go crazy and checking jobs, to be able to make that accessible through the web portal. So stay tuned on that. It's getting bigger and exciting, and versatile is really, you know, again, that scalability, bringing in at every level of the design of the cyber infrastructure.
So yeah, I just wanted to make the point that, you know, these OpenSees builds themselves are not limited to 2 nodes. That's just the way that we're running it through DesignSafe right now. If you need more, that is possible, right? You just have to have your own location. Yeah.
Well, yeah, and you go to TACC, or you could submit them through the Jupyter Hub. Would be the way to do it, instead of going through the web portal. And there's use cases on that. So that right now is actually possible. If you have an allocation, you go through the Jupyter Hub if you want something a little bit more automated than just like the web portal, but with a little bit more control.
So Omid, is your hand up again, or is that from the previous question?
No, sorry, it's from previous question.
Okay, no problem. So Bijan, your turn.
Bijan.
Hi, Sylvia. Thank you for this great presentation. I wasn't familiar with DesignSafe, and now I understood it. Thank you so much. I have a question about the OpenSys Cloud. Is DesignSafe about OpenSys and OpenSys Cloud providing same platform, same activity for us, and doing same action, or they are similar to each other, or there is some differences between them?
They're different. In concept, they're the same, that you request certain nodes and configurations. OpenSees Cloud runs on AWS, and it doesn't. OpenSees Cloud gives you an image, and I don't know enough about it. Okay, but it gives you an AMI, and you run it, and it's different because it's a pay-per-use type of service. DesignSafe gives you other ways, or many different ways, that you can submit your jobs. DesignSafe integrates the data, integrates the whole data depot, integrates Jupyter Hub, other things in it. So they're just different tasks, different ways to approach OpenSees, which again is just AX equal B solution. So they're both ultimately doing the same task, different target audience and different scopes though.
I guess on OpenSees Cloud, AX equals B plus money, right? Something like that.
Yeah, but money is time, so
yeah.
Yeah.
We did get a question as a follow-up to a previous question here in the Q&A. So can you briefly explain how hazard consistent analysis differs from IDA and explain its benefit and relative accuracy?
I would love to, but I can't. It's way beyond the scope here. So Google it, look into it, and it's a fascinating thing. So you'll find different people with different opinions on IDAs and hazard consistent. You can look at the work that Jack Baker has done on his stripe analysis. That is something you should look into if you really want to optimize your analyses. But yeah, that's a different hat.
I think that's it. Hopefully I'm not missing a Q&A or a chat